Hello, this is my presentation video for my data science final portfolio. My name is Alex Bernal. I want to thank you guys for taking the time to review all the work I did for my senior thesis milestone portfolio. An introduction is to summarize the 7 learning objectives of the data science program. The first objective was to describe a broad overview of the major practice areas of data science. This is because data science expands past any single industry group or technology sector. One of the key or major areas of data science is the ability to manage data, clean, collect it, organize, re-engineer it, change the dimensions, manipulate large data frames. That was a major part of every course that I took here in the Syracuse Data Science program. Once you have the data organized in a way that it can be analyzed, then you can really see the value of it through visualizations, statistical analyses, and also pattern data mining. The fourth milestone, or the fourth learning objective, is to develop alternative strategies based on the data, as well as to develop a plan of action, essentially a business case or business decisions derived from the analysis or the data mining or the visualizations that you find within the data analysis. Lastly, you have to develop your communication skills regarding data science projects, because in real world settings, there's not going to be people in management positions or even below you that can understand all the concepts. So it's very important to be able to summarize things, to be able to create visualizations that make it easy to digest what you're trying to explain about what the data is saying about the organization, so on and so forth. Lastly, something that should definitely not be overlooked is the ethical dimensions of data science. With the Facebook case most recently, where there was data science being used for election meddling, and in other countries where they use facial recognition technology for authoritarian means, there's definitely a level of ethical consideration that is necessary for any data science project, no matter what industry you might be moving into. The projects that I featured in my portfolio were really the ones that I enjoyed the most, as far as learning new things, but also the ability to build upon previous skills that I had before I started the data science course. IST 707, the project that I'm featuring, is where I used a machine learning model to predict housing prices. I also used machine learning in IST 687 R programming to predict bike rental data for different parts of the organization, basically financial planning and forecasting. It was really nice to have a mixture of R and Python and other programming languages, SQL, because you got to see all across the whole data pipeline the different tools that are used in those different areas. Then the next one I wanted to feature was probably the most challenging class I had, IST 718 Big Data Analysis. This was essentially using the core programming skills, but applying that across much bigger data sets. We had to really dig deep in a lot of the different areas of this project. It was not just focusing on machine learning, but the full process of collecting it from the web, making data frames together, and then also building different use cases around the data mining and machine learning. Next, I started taking classes in more non-textual or textual data, non-numerical data. So we looked at Twitter data, how to scrape that from the web and analyze that. The fifth class I'm featuring is marketing analytics. I really enjoyed this because it kind of just focused on one area that's really important to almost any organization that has a sales process. And we looked at different statistical techniques, key performance ratios, and indicators around marketing strategy. And we really got to see kind of real life use cases around how, grocery stores orient their marketing around data and web marketing and like social media marketing. The last three I really enjoyed as kind of my senior, my last year was winding up because it dug even deeper into natural language processing. I took text mining, which encompassed a lot of techniques with building corpuses of text data, cleaning text data, looking at different things around natural language, English language phrasing and topic modeling. Natural language processing, we did slightly different projects, mainly document classification. So, with so much data being created every day, it's important to be able to use the power of programs and machine learning to read a lot of text data at once and be able to summarize it effectively. And then lastly, I wanted to feature a class that was different but also very, very interesting because it really focused on accounting and financial fraud analytics. So we looked at cases where we would try to find where salespeople were manipulating their commission numbers, or we were looking for cases where they might have had fraudulent charges within the company, and also we found cases where there was evidence of collusion. So that was actually kind of fun to use different tool sets in that class. So really one of the things I wanted to start with is the core thing I started to put together across the whole course is that as in any scientific process, the data science process has a very, very clear cyclical schedule of actions across any project. You really have to look at different ways of gathering the data, whether it's with a program or having pre-built clean data sets, being able to extract it from the web, being able to reformat data so that it can be ingested. That really moves to the scrub stage or the clean stage, in that you have to have a level of organization where it can actually effectively be used in machine learning or data mining. If you have missing data points or if you have misspellings in textual data, then your output can really be affected once you get further down the process. Typically in the data science process, before you get to any modeling, it's important to actually take a step back and explore the data itself. Look at the dimensions, see if you can get some just base level understanding of how the data behaves, or how complex the data is, what are the relationships between the different factors. And then once you have a sort of business understanding going forward, then you can actually effectively use the right kind of model. There's so many different types of machine learning models and ways to build insights with different statistical programs, that it's important to kind of understand what you're trying to achieve before you just go out and throw it into a bunch of algorithms. Lastly, you have to learn how to interpret these models, understand what are the limitations of hyperparameter tuning. Are you overfitting the model? Are you trying to bring a sledgehammer to a situation where you only might need a tack hammer? I mean, there's a lot of different cases where once you interpret the model, you will probably have to go back, maybe even go back to the scrub stage, clean the data even more, in order to kind of get the insights that you're looking for from the modeling process. The projects I wanted to focus or to display that really showed my skills that I learned with data acquisition was the Twitter mining project in scripting for Python. It was important because I really started to see that there's just so many places where this data is starting to be generated. Obviously the Internet of Things, iWatches, a lot of devices that are connected together, sensor networks, so that's like your traffic cams or your smart city indicators, obviously social networks, so Facebook, Twitter, LinkedIn. These places offer a lot of digital exhaust, and from the digital exhaust you can learn a lot about how corporations are behaving, what their intentions are, and really try to see how they interact with each other. There were some really interesting articles that we learned in this class where 88% of internal data sources in a company are transactions, 73% is essentially log data, and then 57% of the internal data sources have essentially be effectively emails. And outside the company, you typically find social media, audio, which I thought was interesting. We didn't really get to play with a lot of audio data during this course, but I know that there's a ton being made with all the new podcasting tools and the music that people are making on SoundCloud. There's just a ton of different new audio data sources that are coming out, and photos and video. So in this case, you can see on the left, this is just a snapshot of one of the scripts that I created, where it essentially called in a library called Tweepy that it was built to scrape data from Twitter. You'd have to actually register with Twitter, which was interesting because it basically said that you couldn't just be completely anonymous. You had to have some ethical standards to your behavior that made you register with Twitter before you can actually go in and extract the data. So I kind of like this because it really forced the user to really think about what they're doing. If they had malicious intent, somebody is obviously tracking you. And so with that, with a couple functions, we were able to call down. In this case, this was the last 2,000 of Donald Trump's tweets at the time, and we looked at the sentiment and what his topics were, and basically compare that across time. The next stage that I wanted to feature in my presentation was the data cleaning cycle. Almost every project that I did had some degree of data cleaning that took many hours in certain cases, but I just wanted to showcase a couple things that I thought were skills that were applied across almost every project, where we would fill in missing values with zeros or blanks depending upon the modeling, and we would do manipulations so that we can clean the textual data as far as remove the symbols, change it all to lowercase, strip it of any white space, any characters we didn't want to go through the models, and do spell checking and stuff like that before we can actually process it through the machine learning models. And so really I found this nice little image here about the data cleaning cycle. I think this was on like an Alteryx presentation where you import the data. In some cases you're merging different data sets, building dimensions, obviously processing missing data, standardizing it so that when you model it, something that has a very large scale can be easily compared to something with a small scale. That's normalization. Obviously you want to remove duplications in certain cases. And one step that I think that people don't realize is you actually want to have some degree of verification. So we find this in some CRM projects where someone's phone number might not be real, or the country they're in isn't the one they're in, and it's really garbage in, garbage out once you get into the machine learning process if you don't have actually true data. So that step was important to highlight in the data cleaning process. As far as the exploration stage, this also had a cycle, but in Python it was really easy to call a very short amount of code to be able to pull up a lot of the overview programs about the data. So we would also obviously look at how many data points there were, how many were unique, percentage missing, what types of data points there were. So were they characters or floats or numerical values? This was all very important because if you understood the limitations of what your data was before you went into machine learning, then you can kind of effectively do a little bit better cleaning in the step prior to that, or you can understand the output once you get through the machine learning portion. So this was an important thing because you can actually learn a lot from the data set itself before you do any comparisons. That's going to go into your interpretation for the end user. For the modeling stage, I kind of wanted to break this out a little bit more because if you could just throw it into models, there's so many programs right now that are AutoML, and you just plug and play, and I really think that they're blowing past a couple steps in this process that are very important, whereas you have to really understand what you're pushing through the model. It's going to find what it's trained to find in a lot of cases, and if you don't orient the data in the right way before you do the machine learning, you're kind of going to get an output that you might not understand. So I really like this image that I think I found in textbook, where it was just kind of a workflow where did you summarize the data? Did you, try to interpret the summary before you put it in the machine learning? Did you need to change it before you put it into the modeling? And once you modeled it, what were the inferences coming out? Was it mechanistic, causal? Does this data have the ability to predict anything, or is it just inferential? So that was actually kind of something that really goes into the next slide, in that you have to understand the business case or the business intelligence. In a lot of cases, with the accounting, fraudulent accounting class, this was important because it was so focused on one area of data science that it just brought in the understanding that you really need to know about your use case before you just kind of dive right in. You got to do some research. So being able to have in and sample and out of sample, do control groups, different sampling methods, and understand that in a lot of cases, if you're doing business intelligence, you might not need full-blown data science modeling if you're just kind of data mining for certain things. So this was really important to understand and differentiate over the course, because in a lot of cases this became a step before it would go into my data science modeling. So the next course I wanted to feature was the Predicting Coach's Salary. This was a really challenging course for me because we had to basically build everything from scratch. The professor didn't really give us a lot of data sets that were pre-built, pre-cleaned. We had to start from scratch, understand, okay, if we're trying to get to the end, which is foresight, we have to know where to go to get the right data. We have to understand the timing of the data. And really the image on the left is kind of the summary of what I learned in this class, where at some point you're looking at what happened in the past. That's descriptive analytics. You would then move forward using exploratory techniques to understand, well, why did it happen? Then you can use some machine learning or data mining to say, okay, well, what will happen in like any scientific process? If something does this, what is likely to happen next? And then, which is the most valuable for most companies, prescriptive analytics is how we can make things happen. So that's sort of the, goes back to the ethical dimensions. If we, put propaganda on different social media sites, does it, sway an election? So that, you kind of had to keep the ethical expectations throughout the entire process of this course. As far as modeling, we really went deep into a lot of different modeling methods. We modeled time series data. We modeled static data that didn't really have a time element to it. Multiple factor models, which used a lot of different supervised and unsupervised methods. And we did it across multiple platforms, so using the different libraries for RStudio, as well as some plug and play stuff like in Alteryx or Tableau, was really interesting to be able to get my hands dirty in this whole process. So it really starts with this. You got to have your data pre-preparation, your feature engineering, again, garbage in, garbage out. You would split the data sets into training samples and validation samples. You would push it through the model and sometimes use controlled hyperparameter tuning. Also, you could use data pipelines that would test multiple types of modeling methods at the same time, so you can see random forest trees versus linear regression versus logistic. And then this cycle kind of continues, and really till you get test results that you can understand that you didn't overfit, and can give you a very, very solid output of the type of business application that you were looking to gain insights for. So with the modeling process, I had a lot of samples to show, but I wanted to show a couple different stages of this, where we would have to build dummy factors for categorical variables in a model. We would have to build new data frames and merge data sets in order to be able to have the right type of data sets to build over. You'd have to know which libraries to call. You'd have to bring in train test split and different hyperparameter tuning methods. And also you'd have to bring in the performance metrics, because you can train a model, but if you don't understand the performance of it, there was really limited use for the output. So in this case on the right, we had a data pipeline that I built for, I think this was the marketing class, where we tested logistic regressions. We tested different types of logistic regressions with penalty factors. We also tried random forest and gradient boosting classifiers, really to try to see if we can get more bang for our buck every time we ran the model. We can look at the performance. And so you can see in the bottom, this is your kind of classic ROC performance grid, where you're looking for false positives, true negatives, and so on and so forth, to try to see how well the model performed out of sample. Data visualization, this was actually kind of the fun part. Once you had a lot of the coding done and the sometimes drudgery of munging through the data and organizing it, then we really got to make the pretty pictures, right? So we got to build images using bar graphs, heat maps, different distributions, time series graphics. A lot of cases it was scatter plots. And in the Twitter module, we built some network graphs that really kind of get our point across of what it is that we found, and how can we make it interesting for the viewer to understand. And so there's really kind of an aesthetic artistry to this, because there's so many tools out there and so many ways to display data. I think the challenge is to be able to display it cleanly with the idea of making it to the point and effective to the viewer of what your findings were. So some of the samples I wanted to show here that were in the projects that I completed were, correlation graph, where you have not only numerical values but color values to show the differences in the correlations across the different factors. We also went as deep as building animated three-dimensional graphs in the RStudio course. You could see a sample here of the word cloud that we did in the textual mining, and then some of the other Python graphics I used quite a bit were the accordion graphs and the bar stick graphs. So one of the things I found when I was researching some of these things for the course was a really nice quote that says, numbers have an important story to tell, but they rely on you to give them a clear and convincing voice. And I think this was important because, there's so much emphasis on analysis paralysis and, getting all the data processed. But if you kind of step back and take the time to really look at the different ways to visualize it, your message is going to be much more welcomed, and you're going to be able to make a larger effect with the research that you do for your companies. This brings us to the next stage, which is kind of the data storytelling. This was kind of challenging because I was pretty much a numbers guy, and when it comes to trying to think about to communicate this using narrative and also images, there really wasn't a predefined way to do this. So I kind of had to create and look at very successful cases of how to do this. A lot of cases in data science and in quantitative analysis, which I was working when I started the course. It's really difficult, if you've been doing this in such a niche industry, to have layman vocabulary. So the ability to put things in clear terms that someone that doesn't know data science can understand, or with the basic college education can understand. The ability to highlight some of the things that they might not naturally see or be clear with is important to do. Also, if your project has a motive, it's really important to use the data as evidence to have them kind of see why this experiment was so important. Right now there's a lot of really interesting situations where people are using data science to try to make their case for pro or con global warming, or for political actions, or for all different types of things that tips over into the ethical dimension. But really, it's these insights that you can highlight the value of that is going to bring knowledge to your organization and yourself from the data science process that we've learned in the course. So as we wind up our presentation, I wanted to show a couple images that I thought were really good summaries of what I think I learned throughout this course is the life cycle of data science, where each stage of the process has its own kind of important facets that we learn throughout all these courses. And it kind of goes in a circle, because once you get done with the modeling, then you're watching the models and you're retraining and you're building them into applications, you're collecting new data, it just kind of cycles through with new intelligence, and then you start the process all over again. So I really thought this was a great symbol to highlight in my presentation, because it kind of summarized it all in one visual image, just essentially an icon of the storytelling. To touch on the ethics of data science, it wasn't a priority of mine to think about these things until I took the accounting course, and that is essentially all about ethics. It's about essentially using these methods to find places where people might have not acted completely ethical, or to better an organization so they can make preventative measures against possible misconduct. But one of the things that I found was a paper that explained some of the ethics in data science, and really the things that you were reading about, they had a really nice summary for, which was the problem cause solution. Essentially, some people are using p-hacking or different statistical manipulation methods to essentially build their own case or build their own evidence for the solution that they might be providing. So I thought this was, had a lot to do with politics and, social media manipulation during the Trump election. There was a lot of cases of that. Additionally, privacy, this is something that just got enacted recently with the GDPR of Europe, how, they came to the conclusion that your data is your property, and that these companies have to essentially enable you to have the privacy that you need, because we're all connected to technology. So lastly, the couple other pieces of the ethical stance for data science were the limitations of automated decision making. If you build models for everything, like, what's the humanity in that? If you're really going to make decisions about the best thing for one group, it might not be the best thing for another. And does majority rule really, is that really the best thing to do going forward for humanity? So the two case studies I like to reference here are the Facebook case, Cambridge Analytica, and the Edward Snowden spying privacy monitoring. So essentially they were manipulating free will through the, I guess you can call it marketing methods. So a couple pieces of ethics in data science that I wanted to highlight were, you see in a lot of cases that there was cherry picking, so they would strategically omit data. You see a lot of this in, like, the climate change debate. You can either manipulate it through omitting data or adding data that might not be relevant. You can also change the visualization so that they invoke more or less emotion across the image. And also, comparing apples to apples is an important thing to understand. People think that there's more gun violence today, but if you account for the population growth, there's actually less people killed per capita per population than there was 50 years ago. So that's something to take into account. The one on the bottom right I really like, because this had to do with modeling, where you can easily overfit something and get a beautiful little kitty cat if you just run the machine learning enough over the data. These are the cases that I actually found sources to, where right now, what's really interesting is everybody's so focused on the hockey stick case. This is like your Al Gore. We only have 20 years left to live before the world is going to melt. But if you look at the same data collected from a completely independent source, the view of the climatic history of Europe is a completely different picture. So who is right? Who's manipulating data here? And obviously both are driven by their own political agendas. Also, there's other stuff that is very sensitive in politics where, you know, they showed a situation where when cancer screening went down at Planned Parenthood, then abortions went up. And this was a clear case of axis manipulation, because if you really looked at it on the same axis, you know, cancer screenings went down drastically, but if you looked at it the same measure, abortions are pretty much flat over that same time period. So it's kind of a case of manipulating the data and really the ethical stance you have to think of when you're doing these data science processes. So in conclusion, you know, I wanted to summarize, these are my references for this that I directly took for some of the images and some of the quotations. I want to thank you for watching my video. I really enjoyed this course, and I hope to do great things in the data science community in the future. Thank you. Good night.